Your very next workplace colleague will likely not be a human sitting behind a desktop keyboard. It will not draft simple emails, write basic scripts, or generate artificial images. Instead, it will unload cargo containers, assemble electric vehicles, care for elderly patients, harvest agricultural fields, and prepare your dinner while the world remains obsessed with basic chatbots. Tech monoliths have pivoted to the real revolution, physical artificial intelligence. Stay tuned until the final second because human computing is leaving screens forever. For decades, society was assured that the greatest technological revolution would take place exclusively behind digital screens. We were promised smarter conversational models, optimized search infrastructure, and hyper efficiency software tools. Yet, while mainstream attention remained captivated by software assistants, a far more disruptive movement was gathering momentum inside automated manufacturing centers, research laboratories, and fulfillment hubs. An entirely new class of machines was learning to perceive, evaluate, and navigate the physical world. This marks the formal arrival of physical artificial intelligence. Unlike prior software breakthroughs, physical AI does not merely process digital information, it executes real-world physical actions. It manipulates physical objects, navigates highly unpredictable spatial environments, and performs labor right alongside human workforces. According to global technology leaders, this transition is no longer a speculative projection, it is actively unfolding. To understand the significance of this shift, observe the progression of modern computing history. In the 1990s, the global internet transformed access to human information. The mobile revolution subsequently compressed that capability into handheld devices. Recently, generative models revolutionized text, audio, and visual generation. However, every single one of those technological leaps remained confined within the dimensions of a glass display. Physical AI completely alters that paradigm rather than simply interpreting human syntax or classifying imagery. These advanced platforms sense the physical world via advanced camera systems and spatial sensors, reason about environmental context, and execute kinetic actions using robotic arms, autonomous vehicles, and legged humanoid platforms. In modern industrial facilities, robotic systems no longer operate on rigid, pre-programmed, repetitive motion loops. Contemporary embodied systems adapt dynamically in real time. When an item is misaligned, the machine identifies the anomaly, readjusts its spatial orientation instantly, and recovers from error autonomously. Across logistics hubs, mobile units transport heavily cargo while dynamically routing around human operators. Inside healthcare environments, intelligent delivery robots navigate crowded corridors to transport critical medication. In modern agriculture, In modern agriculture, machinery evaluates individual crop health rather than treating whole fields uniformly. Why is this revolution materializing right now rather than a decade ago? The acceleration stems from the simultaneously convergence of several core technologies, high-resolution optical sensors, specialized compute hardware capable of real-time visual reasoning, multimodal spatial foundation models, and ultra-realistic digital physics simulation have all matured simultaneously. Instead of learning through costly real-world trial and error, robots now train inside virtual simulation worlds. Through this simulation to reality pipeline, a system can fail millions of times in virtual environments, optimize its neural policies, and enter the physical environment fully prepared for complex real-world edge cases. Technology leaders like NVIDIA are committing massive capital towards simulation infrastructure, robotics foundation models, and safety systems. Their target is to supply the central operating intelligence driving millions of future autonomous machines across global industries. Historically, automation demanded that humans adapt entirely to rigid machinery. Factory equipment functioned only within tightly controlled environments, following fixed instructions repeatedly, where the slightest anomaly required manual human intervention. Physical AI completely flips this traditional operational architecture. Instead of forcing the physical environment to adapt to the machine, machines are finally developing the cognitive flexibility to adapt to the real world. The most widespread misconception surrounding this revolution is that it serves solely to eliminate human employment. Historical technological shift demonstrate a far more complex reality. The widespread adoption of personal computers eliminated obsolete manual clerical roles while generating millions of high-value technical careers. Physical AI will automate hazardous, physically exhausting, and repetitive labor while driving unprecedented demand for robotics engineers, fleet managers, simulation developers, and human robot collaboration specialists globally. As we stand on the threshold of this kinetic era, the central cliffhanger emerges. Are we truly prepared to share our physical homes, workplaces, and cities with millions of autonomous humanoid machines? Will this physical AI wave solve global labor defects or introduce unprecedented societal challenges? The definitive answers will be revealed in our upcoming documentary. If you could bring an AI robot into your home tomorrow, that exact task would you delegate first? Share your perspective in these comments right now. Smash the like button, hit subscribe, turn on all notifications, and share this video across your entire network. Join the frontier of AI revolution.